On to Chapter 2. In Chapter 2, we're going to be talking about properties of real numbers. So what's a real number? Well, real numbers can be broken down into two subsets, the rational and the irrational. Under the rational category, I have more subsets. I could talk about integers, natural numbers, whole numbers, and we can complete that list when we meet up in class. On the irrational side, there are no subsets. Irrational numbers are numbers that cannot be written as terminating or repeating decimals. If you tried to write it as a decimal, it would just go on and on and on. So, in regards to properties of real numbers, let's first start by talking about the real number line. It's a representation of these numbers. Generally, we use whole numbers as our intervals, and we can graph on a number line. We can use it to compare numbers, to order numbers, to find absolute value, and opposites. Let's start by graphing 3 on our number line. It's just 3 spaces from the origin, and we call that origin our 0 interval there. If I went 3 spaces in the opposite direction, I would have the opposite of 3, which is -3. So again, we can look at numbers and their opposites. We can use this to talk about distance from 0. So I mentioned a minute ago that we generally use whole numbers as our intervals, and those whole numbers, the positive, the negatives, and 0, are called integers. And there are many intervals in between, and we'll be discussing those in just our next slide. Now that we know that just plotting points or graphing points are just solid circles on the number line, let's graph 2 more points. My -4 at this interval and my -5 at this. They want us to write 2 inequalities to represent their relationship. So let's start by saying, since we're looking at -5 being to the left, -5 is less than -4. Okay, that states a relationship. They want a second relationship, and let's reverse that. We could then say that -4 must be greater than -5. So once again, we can use this number line to draw some conclusions about relationships. Not only can we use that number line to represent or compare 2 numbers, we can also use that number line to order a list of numbers in ascending order. Let's start by graphing them. Draw a number line in your notebook and graph them. We'll graph each one with a solid circle at the given interval. One and 5/10 will fall halfway between 1 and 2. The square root of 4 can be simplified to 2. I have 1/2, which is the midpoint right here. And then I have my -3/2, which if I wanted to, I could represent as this mixed number. So there are my points. Let's now order them in ascending order, least to greatest. My -2, my -3/2, 0. I have 1/2. I have 1 and 5/10. I have my square root of 4. And lastly, I have 4. So I can use this number line to graph the points, compare them, order them from least to greatest. It's a useful tool if you need the visual. We'll be spending a lot of time graphing when we get to inequalities on the number line as well. So I mentioned opposites and absolute value. Well, 2 points that are the same distance from the origin but on opposite sides of the origin are called opposites. If I have 2 at this interval and I go 2 spaces in the other direction beyond the 0, I have my -2. Those are opposites. The term absolute value refers to a number's distance from 0. So if we're looking at a number's distance from 0, we might find ourselves with a positive number because distance is referred to in a positive measure. So the symbols would be just these 2 parallel lines. If I see a number in between those two parallel lines, this is asking for the absolute value or the distance from the origin, and that's just 6. The same would be true if I took -6 and said, what's the distance from -6 to the origin? That would also be 6. Now, when I'm looking at absolute value, I'm looking at a positive value. There is always something to look out for, and that would be is if there's a negative on the outside. This is now telling me what's the opposite of the absolute value. Well, the opposite of positive would be negative. When I look at absolute value, there'll be times where you'll be asked to perhaps simplify an expression first before you take the absolute value. So you may have an expression like, which I would first have to evaluate what's inside, and then I take the absolute value of that. Again, absolute value is always positive. Let's simplify. Let's go across. We'll start with the absolute value of -7. Well, absolute value of -7 is just 7 spaces from the origin. The one to the right here says the opposite of. Well, the opposite of the absolute value of -4 would be a -4. Absolute value of 12 is 12. Here's another one where I have to first simplify what's in the grouping, and I get 3. Now I put this last one up so that you were mindful of the fact that this one is not representing absolute value. It is a number in parentheses, and this still says the opposite of, and the opposite of a negative would be a positive. You don't want to confuse these when you encounter them. And now, one last thing before we end our lesson today. If you were given an absolute value equation, which we will be working on in a later section, we might want to get the solution or the values of x that make this statement true. So think about what that value of x is, and we'll discuss it in class today. I'll see you in class.